Hello and welcome to the Ministry of Bridges channel, your YouTube Bridges channel. My name is Gabriel Neves and I'm back to your Ministry of Bridges. Today, I'm going to speak with Jason Peck, Vice President of Apex Structural Design Ltd company in Canada. Who is Jason Peck and Apex Structural Design?
Well, I am the Vice President and co-founder of Apex Structural Design. I've been using Tekla as of this year, for 20 years. And Apex, we are a steel detailing company that specializes in unique projects in North America. And I would say 15 years ago, we were probably mostly working 99% industrial steel, but now we've spread out into so many different areas that it's hard to say, to put us to label us as this sort of company, but we try to do the jobs that no one else wants to do, and or maybe no one else can do. And the commercial jobs, we're also specializing in residential, high-end residential and public art. And 5 years ago, we won the Global BIM Award for a public art project, which was a steel tree, or a series of steel trees that we did on Tekla.
That was a great introduction, Jason. Thank you very much. So maybe we move on into the bridge. Do you mind to introduce this bridge and let us know what was your role within the project team?
Well, this bridge, we can't take all the credit. Obviously, we are the steel detailer, and so we work for the steel fabricator, and our goal or our job is really to hold the hands of the engineer and the fabricator so that these designs can actually be built and work like they're supposed to. And as a detailer, our objective is to make everything fit 100% on site, so there is no rework required. And a job like this, as we'll maybe see later, that making it fit the first time is of the utmost importance.
I think the same bridge located elsewhere, it wouldn't have the same impact. Where is this bridge located? And let us know a little bit the story about the location of the bridge, please.
Right. So the Whistler Skybridge is located in the village of Whistler, which is about 120 kilometers north of Vancouver. It was the host of the 2010 Winter Olympics, and this bridge is 2,100 meters above sea level, which places it over a mile, and it is considered the highest pedestrian bridge in North America.
Wow, that is something of spectacular, I believe. And what about the design? So the idea, why was this bridge built?
Well, Whistler is mostly known for winter sports, such as skiing and snowboarding, but this bridge was designed as more of a summer attraction for hikers, mountain bikers, and something to just attract tourists in the summer months.
And what about the challenges? We know that it's very high. We know that probably the access is not very easy. So what were the special considerations for the construction in the alpine environment?
Right. So the alpine, the cold weather is the #1 factor. The steel was designed to withstand minus 40 temperatures. The vegetation is fragile, and so no large staging area was allowed. And this is the reason why helicopters were used to install the larger beams, which there were 4 beams of 5,000 pounds each installed with helicopter, and no field welding was allowed either. And by the time I'm trying to think back to 2017, the weather originally was designed to be installed in the fall of 2017, but the weather came early and the schedule was pushed back to spring of 2018, and the snow was still falling in June. It was open to the public by summer of 2018 as planned.
So the picture we are now seeing, that we can see, is under construction and we have lots of snow. When was this picture taken?
The picture with the snow was that was probably taken in May or June of 2018.
The workers were not just experts in steel assembly. They need to work on heights. Any story about that subject?
Well, when those helicopters were coming in, the erection crew was experienced, but there's a lot of things that could go wrong. The helicopter pilot is trained to, if he comes into a problem, he's with wind or whatever, he's supposed to drop his load, which would have been catastrophic. But they really went off without a hitch, and the crew had to use hand signals because of the noise. They could not hear each other, and so they really had it down to a science, and it all got done in one day. I mean, we had meetings about this, about sort of how the steel was to be designed and built in such a way to make it easy and as fast as possible on site to be bolted. So what we're talking about is the large cantilever platform. The largest section was done as a large welded frame, and that was dropped into place in one go.
Here I can see that the beam and making sure and modeling everything to the high level of detail in Tekla in order to do the less work possible on site.
Yes, and the shop does not normally trial fit our pieces together, but in the case of this platform, they did put it together in the shop, and just to double check, make sure it all fits before they shipped it to site. And that's not normally the case, but we're quite confident that our Tekla models are 100% accurate.
And what about the environment and the design? And how challenging was that for the design, as far as you know, of course?
So there was a lot of discussion about the bridge itself and the decking, and how would it hold up under winter conditions and quite a large snow load. And so it was determined that we should decommission it in the wintertime. So that is why we used 100 different decking modules, and these are smaller pieces that can be removed for the off season. And that had to do with also not knowing the buildup and how it would affect the below the bridge, what would happen. That is why it was done that way, and actually turned out to be a good way to erect it as well, and as one module at a time.
You're saying that during the winter they take parts of the bridge?
It is designed to be taken apart every year. I mean, there might be a time where they leave it up over winter, but as far as I know, that's not happening.
Let's jump into numbers. So what are the dimensions of this bridge?
Well, this project there's really 3 phases to this for us. It was, the first phase was the large abutment frames on either end had to be installed. And then the second phase was the bridge itself, which is about 420 feet long, clear span, and we're 130 meters. And again, highest above sea level in the world, but North America, sorry. But and the final phase was the Cliffwalk cantilever platform, which extends from the rock face over 20 feet, 40 feet, and is really attached with, I think, 12 rock anchors. And the bridge itself is attached with anchors on either end as well. So you've got the bridge itself, when we double checked, it was about 1,700 individual parts. There's a lot of repetition, but there was quite a lot going on.
Once again, was BIM crucial to make this project successful?
Yeah, for sure. I mean, the design meetings we had at the beginning were, I hosted those meetings with a Tekla model so that the entire team could see what was happening. And we, talking about things like the guardrail, what looks good aesthetically, plus what is also safe and easily fabricated, easily erected. But BIM, in Tekla, I would say, we had a lot of, the frames on either end were both compound slopes. And those type of calculations were made a lot easier using Tekla, and the cantilever platform as well had some curvature to it and camber requirements, which all were made easier with Tekla.
That I'm so happy that Apex is doing some bridges once a while. So I know you have all those nice statues, but it's very sexy doing bridges. So
Apex, we are not a bridge detailer. We're not a concrete detailer, but we've done quite a few pedestrian bridges over the years, and we find those bridges are like snowflakes. They're very unique, every one of them, and always bring their own challenges.
If we jump into some final thoughts, so what is the legacy of the Skybridge and the Apex involvement into this kind of project?
Well, I think that the Winter Olympics in 2010 really sort of, showed off Whistler to the world. And in this type of project, being galvanized steel, this bridge should last forever. Another attraction for Whistler and British Columbia and Canada. In terms of Apex's involvement, this bridge is not too far from our office in Vancouver, and we pride ourselves on these types of specialty projects. And for this one being so close, it was extra special. And winning the BIM award, the North America 2019 award, was really just a bonus for us.
And well deserved, So Jason, I invite you now to comment a couple of images that are now on the screen for our viewers to know a little bit more about the story of the images.
This image here is the Cliffwalk cantilevered platform that sort of juts out from the rock face. And here you can see quite a bit of the grading platform and the wire mesh screens that were put up. Those are mostly so people wouldn't lose anything when they dropped them. But the grading was actually done with a custom Tekla macro that we've developed here at Apex. So you could basically see every bar of the grading in true position. This picture is from the shop, and this is maybe the largest welded frame on the project that was dropped into place.
And how is the workflow here on the shop?
We mostly supply the shop drawings. This shop uses shop drawings in their shop and CNC for the plates. And the erection crew actually did use tablets with Tekla model viewers on them that we exported so they could really see what was going on in the field.
Do you model weld?
Yes, we do. We model welds. We try to model them 100% in our models, but so it's a combination of showing them in the model and on the shop drawings.
All right.
Right. So this is this image is the abutment frame, sort of the A-frame at each end of the bridge, and those are two frames that are bolted together at the top. Two welded columns with the sort of compound sloping geometry in both directions. And there's also 4 saddles for the 2-inch cables that they sit on and are, tightened on each end. That is the saddle, and it's a real custom piece of steel there. To have that, to roll it like that, and it had the big groove in it so the cables could sit in. This image is the trial mock-up in the shop of the cantilever platform. So this is those 4 beams. Each one of those was dropped in with a helicopter and bolted in place, but they just wanted to make sure it all fit together before they did that. I think this shot is a picture of the final install before the public was allowed on. It's really hard these days to get a picture without somebody on it. So that's just a quick shot of our Tekla model. The cantilever in this model was actually not modeled in true position, but they were separate from each other, so it wasn't a big problem. We also modeled the bridge as a straight run. We did some testing on the sagging of the rods or of the cables, sorry, but it was mostly detailed flat, just for so it can easily be placed on a drawing. This end of the bridge, it's a little hard to see, but you can see this is how the cables were anchored into the ground, which would be the red. And there was quite a lot of embedded steel as well to attach these rods and clevises. It's quite a scary platform to stand on, and if you have a little bit of vertigo, you might not want to wander out to the edge. But for the brave and the adventurous, it's a lot of fun. There you can sort of see what it looks like from the village below. There's a Canada flag.
Yay. Very cool.
In this shot, you can see the tram on the left that takes you up there. Every bar that you see is placed in true position, and it makes it a lot easier to visualize and model, especially at this instance where we have 2 different screens coming in at the abutment and a lot of different geometry going on.
I have one more final question. What is Apex doing in preparation for the next BIM Awards?
That's a good question, and we really love to place our projects in those awards every year. And with all the different categories that they have, it really opens up things for us where it used to be kind of maybe a couple categories. And, you know, we have a large mine shaft project that we're working on, which is basically a skyscraper under the ground. And you know, that's one we're looking forward to you know, being nominated. And we have that would be like a large category. And then the smaller categories, we have quite a few projects on the go, you know, whether it be public art or maybe some, you know, residential projects that are really pretty cutting edge, and, you know, projects that we're all really proud of.
Jason, I wish you all the best personally and professionally, and all the best for Apex, and for our viewers. Watch this space and have a look next year on North America, Tekla North America BIM Awards, and then hopefully into the Global BIM Awards for Apex projects.
Thanks to the Ministry of Bridges.
Thank you, Jason. I hope you agree with me that this bridge, it's very, very cool. Let's smash the like button, and please drop as many comments as you want using the comment box below. I really enjoyed having this chat with Jason. See you in the next episode, and have a Bremer day.